Hi, this is our discussion for Wednesday, April 8th. We're up to number 57, getting near the end. So here's something new for today. Remember that if we have something to a power times something to a power, as long as these bases are the same, there's 2 to a power times 2 to a power, we're supposed to add the exponents. So we would get 2 to the 3 plus 0. And 3 plus 0 is 3, so we're getting 2 to the third, which, by the way, is 8. Let's go back here for a minute. We started with 2 to the third. We multiplied it by this, and we got the answer 2 to the third. I'm going to leave this blank here. We're going to figure out what does that 2 to the 0 have to be. Look at the next example. We got 7 to the second, which is really 49, right? Times 7 to the 0. Again, we would add the exponents. 2 plus 0 is 2. So we're getting the same number we had here after we multiply by this. So think about this for a moment. What behaves that way in the world of multiplication? What do you multiply by? And the result is the same number you started with. It's our old friend, the number 1. So 2 to the 0 is 1. 7 to the 0 is 1. And if you stop and think about it, if I have any number to some power times that same number to the 0 power, I'm going to get back the original number here because I'm going to be adding 0 to the exponent, which means no change. And so we can say that, I'll talk about that in a second, x to the 0 power, meaning any number to the 0 power equals 1, except 0 itself. 0 to the 0 power is undefined. And we'll talk about that some more after we get a few other ideas out of the way. It won't make much sense right now. But anything except 0 to the 0 power equals 1. And hey, don't take my word for it. Here's the calculator. Here's a nice big number, right? 5,641. I'll raise that to the 0 power and I get the answer 1. I'll take negative, well, put it in parentheses, negative 3, 5, all this to the 0 power. Still get 1. I'll take a nice small number, 0.0005 to the 0 power. I'll get 1. Now watch what happens if I do 0 to the 0 power. I get domain error, which means the number we used doesn't behave, it isn't usable that way. Domain is the set of all numbers you can use as an input. So you'll learn more about that in 1075. So let's go over here now. We have 3 to the 2 times 3 to the negative 2. What are we supposed to do with the exponents again? Add them. And if you add 2 and negative 2, you get 0. The next one. Add the exponents. We get 4 to the 0. Now, what did we say about the value of these things? Something to the 0 power. This is really a 1. When we multiply these together, we got the answer 1. When we multiply these together, we got the answer 1. How much is 3 to the second power? That's 3 times 3, that's 9. So we're saying 9 times this equals 1. What do you multiply 9 by and you get the answer 1? Think about that for a second. And over here, this is 4 to the third is 4 times 4 times 4. That's 64. So whatever this little thing is, when you multiply it by 64, you get the answer 1. So, got an idea yet? 9 times 1 over 9, 9 ninths makes 1. If this was 1 over 64 here, 1/64 times 64 equals 1. See, what this negative exponent really means is that you have 1 over that same base to the positive power. See, there's another way of writing 1/9. 4 to the negative 3 really means, 4 to the negative 3 really means 1 over 4 to the positive 3, which is 64. So it's really not negative, it's really more like inverse. And you even see that on the calculator. If you look right here, see this key, x to the negative 1? If I put a 2 and then do that, whoops, wrong key. If I put a 2 and then hit that key, 2 to the negative 1 power, that's 1 over 2 to the first power, which is 1/2. So it shows me the decimal for 1/2. See that? So what we're learning here is, again, x can't be 0, then it doesn't get defined, but anything to a negative power is equivalent to 1 over the same thing to the positive version of that exponent, or opposite power. Okay. On to the next thing. How do we simplify fractions like this? Well, what does this really mean? X to the 5th power. It means x times x. Let me use all the space. That's what x to the 5th is. That's the numerator. And that's x to the 2nd. That's the denominator. What can I do to simplify this? I've got a pair of x's here and here. I can cancel them. As you know, x over x makes a 1. I can cancel. I can cancel another pair. What's the result? What's left over? Just x to the 3rd power. So this turns out to be equal to x to the 3rd power. I don't want to do this all the time. Let's see if we can figure out a shortcut. How about this one? If I rewrite this, not using an exponent, I'm putting 2 factors of x in the top, the numerator, and the 5 factors of x in the denominator. And one more time, I can cancel those, but I canceled everything in the top, so I need to leave a 1 up there. So we get 1 over x to the 3rd. So for this one, we got x to the 3rd. For this one, we got 1 over x to the 3rd. The number of x's pairs that we could cancel turns out to be, whatever the smaller exponent was. And you do this a few times and you notice, hey, I don't have to draw all these x's. I could just subtract the exponents because the 2 from the 5 are going to get disappeared. Same thing here, 2 from the 5 are going to get knocked off. Where will there be x's left over? Wherever there were more x's to begin with. In this first example, there were more x's in the top of the fraction. Here there were more of them in the bottom of the fraction. So, very simple rule. When you have something to a power over the same thing to a different power, you reduce by subtracting the exponents, leaving the thing, the base, the x, the whatever it is, wherever there were more of them to begin with. So now we can do these, and I don't have to draw out 20 x's and 17 x's. I can just say, well, there's more x's in the top than the bottom, so I'm not even going to have a fraction anymore. I'm going to have x to the 3rd power. That's the end of that. What do we think here? There's more x's in the bottom, in the denominator. So I'm going to have 1 over x to the 39, take away 35, is 4. What about this little guy? X to the 4th over x to the 4th. Well, it's the same top and bottom, right? So I could say, well, I'll say I don't need a fraction anymore. I'll say the top is the winner. And 4 take away 4 is 0. And as long as x itself isn't 0, as was said 10 minutes ago or so, this is equal to 1. That makes perfect sense because we learned a long time ago if you've got the same exact number top and bottom of a fraction, the fraction equals 1. See how that holds together with everything else we know? So, that's all it says down here. In simplifying these, we first answer the question where, numerator or denominator, top or bottom, is the larger power of the variable. We subtract the exponents, and the variable stays where its larger power term was, where there were more of them to begin with. So, let's go down here and talk about these things just for a minute. What if we just blindly obey the rule x to the m over x to the n equals x to the m minus n? This is written in your book, so it's saying the answer is, to simplifying that, take the exponent from the top and subtract the exponent from the bottom. So if we do that here, 20 take away 17 is 3. No problem. And that is what we would get looking at this with the approach from higher up on the paper. Bigger powers on the top, so we keep the x on the top and we don't need a fraction anymore, and we subtract 20 take away 17. We get exponent 3. This one we would say, oh, it's on the bottom, so we keep the x on the bottom and we get 1 over x to the 39 take away 35. But supposing we just use this, top minus bottom exponent, well, we would get x to the 35 minus 39. How much is that? That's negative 4. So everything's okay. The only thing is we don't like to have an answer with a negative exponent, so we would change this to 1 over x to the 4th. But wouldn't it have been more efficient to just look at this in the first place and say, hey, there's a lot more x's in the denominator than the numerator, so all the numerator's x's are going to cancel, but there'll be 4 of them left over downstairs. Okay, so the bottom of this paper, and we'll end this page 1 video. If m is greater than n, in other words, if this exponent, the one on the top, is bigger than that exponent, then we get this answer. No more fraction, x to the power, bigger exponent minus smaller exponent. And if n is greater than m, if this exponent is the larger number, if this is larger than m, then we get the answer 1 over x to this number minus that number. So it's all a matter of which exponent was larger to begin with. So that's the end of page 1.